Good morning, George Hepworth, Grover Park Consulting. Welcome back to the Northwind PowerApps series. In this video, we're extending our look at the stored procedures that power the CRUD logic for order details. This logic, which is similar in all of the other entities in Northwind, including orders, and purchase order details, etc., can be implemented in other applications where this same design pattern fits. In the previous video, we explored the CRUD order detail master procedure and walked through the first sub-procedure, Z, add order detail. In this video, we'll cover the remaining three sub-procs, Z, select order detail, Z, update order detail, and Z, delete order detail, plus the custom error handler. Unlike the four CRUD sub-stored procs, though, custom error message works as is in all of the other CRUD stored procedures. In other words, you need to understand the design patterns for the CRUD operations where the custom error message is fully reusable. Just as a quick recap, CRUD order detail is a master stored procedure. It receives all necessary parameters from PowerApps. Then, based on the value of the flag, CRUD type, it calls one of four sub-procedures: create, read, update, or delete. In the last video, we focused on the create path. Now let's walk through read, update, and delete. Select order detail. This sub-procedure runs a select query on the order details table. Its main strength is flexibility. Filter field parameters have a default value of 0. So, unless a specific value is passed in, it gets ignored by the where clause. This means the same procedure handles reading one record by primary key, getting all order details for a specific order ID, filtering by product, by quantity, or any other field. The data is returned as a result set, the select clause. Meanwhile, error code and message are also returned to let PowerApps know whether the query was successful. That kind of flexibility means we don't need multiple stored procs for different filter combos. It's all baked into one where clause. There is one downside to this design approach. Because the filters are baked into the design, users don't have flexibility to create their own unique filtering. I can justify that for the Northwind scenario. It implements a specific predefined business model. Flexibility beyond that baseline isn't supported for end users. It's a trade-off, just like many others that went into the Northwind template in the access side. When additional reporting features are added, that's where more flexibility will be required. Now let's look at updates. It follows a similar pattern, but with one key difference. The update procedure checks current product inventory and adjusts the order detail status accordingly. That's done through two helper procs, product available and product on order. We use calculations based on the results of those two helper procs to decide whether we can allocate the product for the specific order. When the product available to sell is greater than the quantity on the order, we can allocate it. When the product available to sell is less than the quantity on the order, and we also have current product on order, we put it into on order status. And if neither of the two previous calculations apply, then we simply say no stock status for that product on that order. Once we've established the order detail status, we proceed to update the order details record. Here's the important part, using the isNull expression. This ensures a user doesn't accidentally override existing data with nulls or the default values unless that's intentional and permitted by the user's role. Of course, if an admin function is later implemented in which a user in the admin role can override data validation we're aiming at here, a different set of admin level stored procedures will be added for admins. Keeping user level functions separate from admin level functions is good design, regardless of the code environment. All updates return a status and a message, just like inserts. Our third and final sub-stored procedure for CRUD operations, delete orders. This is a simple one, but not without a safeguard. Before deleting an order detail, we check the status of its parent order. If the order has already been invoiced, we block the deletion. This is what I call a defensive delete, a safeguard against breaking your accounting or audit trails. If the order is still in a new state, deletion proceeds. Otherwise, PowerApps gets a meaningful custom error message. By the way, I could use constraints in the database tables for such situations, and in some cases they are implemented. In this specific situation, though, I wanted the validation closer to the process, where I could handle it better in a custom error handler. I'm not saying one approach is better than another. I'm saying that sometimes we have choices. Being consistent is more important than being fancy. The custom error message is next. All sub-procedures include try-catch blocks. This allows us to handle unexpected errors, that is, errors other than those such as an attempt to delete an order detail from an invoiced order. That's something we can expect to happen. Because we can't anticipate and provide handling for every conceivable error, we add this general error handling procedure. When an error is caught, the error number is passed back to the master stored procedure. If the error code is not 0, the master procedure then calls custom error message to translate that code into our user-friendly message. Custom error message receives the non-zero error code from the master CRUD stored procedure. It also receives the table where that error occurred. It defaults to a generic object, but it would normally be orders, order details, and so on. It sends back a custom error code and a custom error message. These custom error codes and custom error messages are stored in a table called SS errors, where each SS error ID maps to a templated message. There is a default to allow for those error messages we haven't already anticipated and provided for. Otherwise, it looks up the error message, the custom error message based on the error code it received, and sends back that custom error message, replacing curly bracket 0 curly bracket with the appropriate object. And again, that would be order, order detail, company, and so on. Again, if we happen to encounter an unexpected error code inside this stored procedure, we have no choice but to throw back the raw SQL Server error number and error message and hope that the user passes that information back to the developer. Notice that I've stubbed in logging code. At some future point, we may add logging for errors. Just to close the circle, back in the master CRUD order detail stored proc, when we execute our custom error message, get back the custom error message, this is what gets sent back through the output parameter to PowerApps. This consistent pattern through all of our master stored procedures makes it easy for PowerApps to show toast messages. For Access developers not familiar with the term, they're called toast messages because they just pop up in front of the screen. It allows PowerApps to decide whether to refresh the UI and handle errors without ever needing to parse raw SQL output. That last is the primary consideration from my point of view. So that's how we handle read, update, delete, and error messaging in SQL Server for order details. If you're an Access developer moving to PowerApps, think of these stored procedures like your VBA functions. They're modular, reusable, centralized, and patterned. Eventually, we'll tie all those CRUD procedures together with a full transaction walkthrough from order entry to invoice. Thanks for watching. Be sure to like and subscribe, and keep building smarter.